Hello? Hello?
Initially I thought I'll bring a video, but I went through all my videos.
Yeah.
I think they were too involved for this subject. So I thought I'll just bring one picture.
Yeah. Okay. What do you think? Do you have any idea? Because we are doing this research on the critical zone.
So,
and critical zone is always something which has to do with life, yes, on Earth. And now in your research, there is no life, or in the field of your research, yeah?
Yes.
There is no life.
And without a field, there is no life. So,
that's right, yes.
So what I understood from this is that these termites in Australia, they build their mounds which are elongated in the north-south direction approximately, which is why these termites are called magnetic termites. So, so they did two kinds of investigations. Why are these mounds elongated and in the north-south direction, and these termites seem to be facing east in the mornings while making this. So actually the termites themselves are called magnetic termites, but the reason for making these does not appear to be the magnetic field itself.
It's not the magnetic field itself.
No,
But
it is because it is an adaptation to achieve thermostability because of variable ambient air temperature.
okay.
So that is the reason for this north-south orientation.
Yeah.
Although they are called magnetic termites,
Yeah.
the north-south orientation itself is not because of the magnetic field.
I see, yeah.
It's just a name.
It could be also sun or other influences.
Yeah. So the air temperature will actually cause minimum disturbance to these mounts if they are aligned in the north-south direction. That is their conclusion.
Yeah.
So that way, I mean, although the name says that these are compass termites, it is not clear from this paper that...
It's an old paper, and I think there are, that's the only one I got in a quick research. But I think there are mammals which use magnetic fields for navigation, like certain birds.
Birds might be using,
But maybe this was just one idea, how to connect your research to the critical zone. Do you have any other idea which comes up, how to... I mean, the interesting thing is that your research is done on the surface by humans, by human brains, living entities, and they look towards something which is in the very inner of their living system, and which probably is dead. But do you have any thoughts about?
I think the present day human beings have been inhabiting the earth for about 40,000 to 100,000 years. Is that right?
Approximately 150, I think.
Yeah. So there is evidence for the that the earth had a magnetic field at least 3.4 billion years ago, which probably suggests that the presence of the magnetic field has produced a protective cover for our atmosphere, which enabled evolution to take place, and human beings have eventually evolved as a result of this process.
Without the magnetic field, you said all the cosmic
Rays would have attacked our atmosphere and life would not have been possible. So now life has advanced to such an extent that we have been able to start probing into the reasons why we existed as a race. So from that point of view, it's attractive to actually know these things, because the conditions which allowed us to exist took place much before we came to the planet. And the other point which I can say is what I mentioned to you yesterday, that although we measure the trace of this magnetic field on the surface of the earth, its origin lies completely elsewhere, and but we need to be here to actually study that. We cannot go there. So that probably emphasizes the need for us to be in this zone, in a sense.
When I was watching that the experiment of your student yesterday, which is fascinating, really fascinating, because he does it on, let's say, 20 square meters. He's got his little model, highly sophisticated, with lasers and fluid and circular movements and particles in it, and video tracking in order to see how they behave in this dynamic field. Then he's got a little workshop where he's doing building things for the model, and then he's got a desk with a computer on it, and the computer is also used in order to make the model run and to get maybe data out of it, and then he's doing computer simulation as well. Now if he talks about it, he's totally absorbed, of course, by his ideas, like all we researchers are. So in a way, one could consider that this is like Donna Haraway is calling that, an American anthropologist, playing the God trick. Now he's setting up a little world, yeah, and he's even in that little world, in this little lab, he's building an Earth model, and I would assume that in a way also this Earth model is a cylindrical one and not a spherical one. Yeah? One gets the feeling, at least I got it when I saw it, well, this is the Earth. This model is representing the Earth. Like the Earth is rotating as a sphere, this is rotating, and I can manipulate it, I can speed it up, speed it down, and play with it. So what do you think as a researcher? This is a seduction a bit. Yeah, we think, well, this is Earth. Of course we know it's a model. Yeah. So how would you discuss this?
So we all know that the Earth rotates, and we know that it has a magnetic field, and we know from seismology that the Earth has different layers. So we have to piece together all this information and think of a research methodology which will help us understand how the Earth's interior works. So we start from first principles. So how can we actually simulate an Earth in the space that is available to us? The computer is a possibility. The computer has got its limitations. The experiment has the advantage that we can actually see things, which is not always possible in the world of computers. computers are always full of numbers. So we thought, at what speed should we rotate so that we can get an Earth-like behavior? What should be the geometry of this setup so that we can best capture the inside of the Earth? What should be the fluid that we should use inside so that it helps us understand
Because it's fluid iron
in the Earth's interior, but we are using water.
Yeah.
Why we are not using iron is that iron is opaque, and we cannot use optical measurement methods to actually see with our eyes what is going on. Whereas water is transparent, and although its physical properties are different from that of iron, we can actually shine a laser, use a camera to actually study what is going on. So we have to make these kind of small compromises to actually visualize the kind of things that happen in an experiment. And from whatever we glean from such an experiment, we try to extrapolate to what might be happening in the core. And so this is actually a thought experiment. 3 years ago, this experiment did not exist. It was entirely a thought experiment. But gradually we started putting together all the pieces. It came to be
And then the thought experiences realizes or materializes. Yeah?
materializes. It takes time, but now we have a better understanding of what happens inside the Earth than we had, say, 3 years ago. And that emphasizes the importance of actually having an imagination going on in our mind, and see how we can convert our thoughts into reality. But we should not do this blindly. We should also have some idea as to what we are doing. So we must obtain as much information as we can from books and papers, and then piece together what is likely to be the best possible model to actually simulate the Earth.
What do you want to find out in your life? What is the thing that is your curiosity about the inner Earth mantle, or this dynamic zone in between 3,000 kilometers beneath the surface? What is your crucial question? What do you really want to find out in your life about it? If you had one wish, yeah, and God gives you the answer, you've got one question to answer, to ask.
One question that I would like to answer with my present knowledge is how do planets like Earth function in the way they do? There are several planets in our solar system. Many of them behave alike. Some of them resemble moons of some planets. Some of them have resemblances with stars, not only in our galaxy, but also in other galaxies. There are some planets which had elements conducive to life, but life never took off in those planets. Fortunately, in Earth, we had all the necessary ingredients for life. How do certain planets or certain astronomical bodies develop the right conditions for formation of life, whereas other planets are unable to do that? This is an important question. If I go back to the early part of Earth's formation in our solar system, Earth and Mars together formed at the same time. Both these planets, sister planets, had magnetic fields when we got started off with. 500 million years after the planet's formation, Mars's magnetic field died out. Earth's magnetic field stayed on for 4.5 billion years. Mars, now we know, had all the ingredients of life, like water, presence of rivers, and so on. It is very likely that the termination of the magnetic field on Mars prevented life on that from growing on that planet, whereas the evolution of magnetic field on the Earth allowed life to thrive and prosper in our planet. So it's very essential to know, are there other astronomical bodies in our solar system or in other systems which have the right ingredients as we do in Earth in order to support life. So this branch of knowledge has got relations with astrobiology, where people search for life in other planetary bodies. So that is very much the, I would say, an important objective of the kind of work that we all do.
That is interesting. So you would say no magnetic field, no critical zone, no light.
Exactly.
And the proof of concept is Mars.
Yes.
Yes.
Because both of us formed at the same time. One planet failed to actually sustain it. We succeeded. We have life. Mars doesn't.
Why did the magnetic field of Mars, what is the assumption, why did it die?
There are several mechanisms which have been put forward. One possibility is that Mars started with a core in its inside, but the core of the Mars planet rapidly cooled, and the fluid motion inside the core of the planet died away, and as a result of that, the induction process which sustains the magnetic field of the planet could not be supported. There are other mechanisms which have been put forward because of bombardments from meteorites on the planet. There could have been events in the Martian mantle which could have suppressed convection in the planet's core. So the scientific community, the planetary community has come up with a lot of possible explanations for the termination of the Martian dynamo. But we do know that Mars had a magnetic field because the probes which have been sent on spacecraft have actually measured a remnant magnetic field on Mars. So we know that it had a magnetic field, we know that it died away, and we knew that there were some ingredients of life that were possible.
Could that happen on Earth as well? And
Yes.
how long would it take to die?
When convection in the Earth's core stops, the magnetic field also would stop. But Earth's core is 2200 kilometers thick. So I don't know if I'm being recorded, but this layer is the layer which supports life on the surface of the planet. And this layer is 2200 kilometers thick. And this constantly keeps moving. This is a highly turbulent medium. This is the medium which actually generates the magnetic field which comes out of the planet and supports our life and also the life of lesser mammals that we see on the surface. So it's very important to know that starting from termites all the way to lower mammals, all the way to the highest form that we have on the planet, Homo sapiens, they're all being supported by the magnetic field that occurs in the planet's interior. So what would happen if this planet's interior stops convecting? The magnetic field would die away in a matter of, say, 20,000 years to complete zero.
That's very fast.
That is very fast. And if it dies away, we would have high velocity cosmic ray particles and solar wind attacking our atmosphere and making life impossible to survive. So, in a sense,
What are the parameters or the factors which make it die? Does one know about that?
well, there are several factors which can cause a loss of magnetic field. The planet is really small. It can cool very fast. It cools very fast. It will stop convecting after some time, and that is when the magnetic field dies away. And this is, as I said, one of the plausible mechanisms for the termination of the Martian magnetic field. But if you look at outer planets like Jupiter and Saturn, they have magnetic fields which are much, much stronger than what we have. But Earth has many more ingredients for life than these planets have to support life. Like we have a substantial amount of oxygen in our atmosphere, which has evolved over millennia, and this is an important ingredient of life which does not exist in some other planets. But for an atmosphere to evolve over time, there must be a magnetic field, and that is, I suppose, what makes our research so rewarding. We have now the ability to actually understand what goes deep inside our planet and supports life.